In this problem, we're going to take a look at a couple optimization problems. That is, we're going to try to find the values that will give us the maximum or minimum of some quantity. The first example, we have 3,000 feet of fencing to enclose a rectangular corral that, because it's adjacent to the stream, will only need 3 sides fenced. Our goal is to express the area as a function of the width, to determine domain, acceptable x values, and then find the dimensions that maximize that area. On these problems, I like to draw a picture because that often helps me figure out what the formula is going to be. So I have my stream where we're not going to fence, and then I have 3 sections that we will fence. I don't know what the width is, so I call that x. Because I have a rectangle, that means the other side is also x. So in total, I've used x and x, or 2x feet of my fencing. If I start with 3,000 total, take away what I've used, that tells me the quantity that is left for the remaining side. Now from geometry, we know that the area is equal to the length times the width. So I look at my picture and I take the length times the width, and I've got my area. We'll simplify that to get a of x is equal to 3,000x minus 2x squared. Okay, so the domain is the acceptable x values. In this problem, it's not because we'll get an unreal number because of a formula, it's because of the context. So in this problem, x and this 3,000 minus 2x are representing dimensions. That means they're going to have to be non-negative. Okay, so that means x has to be greater than 0, 3,000 minus 2x also has to be greater than 0, or we're not going to get a rectangle. Solving the second inequality, we'll subtract the 3,000, divide by the negative, and remember, when you divide by a negative, that's going to flip that inequality symbol, and we get x is less than 1,500. Putting these two together, if x is greater than 0 and less than 1,500, that means x is in between the 0 and 1,500. So that's my domain. We could write that as an interval as well, 0 to 1,500. The last step was to maximize, find the dimensions that maximize the area. Well, area is found by this function up here. If we were to graph this, it would be a parabola that opens downward. And we know then if it's a parabola that opens downward, the maximum will be at the vertex. We've used a formula before that tells us how to find the x coordinate of the vertex, and it's x equals the opposite of b over 2a. b is always the coefficient of the x term, and a is the coefficient of the x squared term. So in this particular function, the b is 3,000 and the a is negative 2. Putting those into my formula, I come up with 750. So that's one dimension. How do you find the other one? We'll look back at our picture. The other side was given by the expression 3,000 minus 2x. So if I put the 750 into that, we will get 1,500. So the answer here would be 750 by 1,500 for the maximum area in our corral. This next problem is very similar, but there is an important difference. We are dealing with 60 yards of fencing, and we're doing a rectangular garden. But this time, they don't tell us that there's not a side to fence. We're actually going to fence all of the sides. Okay, so again, I'm going to draw a picture and then think about what that means. Like before, we're going to make one side be x, which means its opposite side is also x. And it also means that we've used 2x, in this case yards, of fencing. Our total is 60 yards, so we'll subtract the 2x from the 60, but all of that can't go on one side because we have 2 sides to split that between. So I take my 60 minus 2x to find out how much is left, divide that by 2, and simplify to say, oh, so that means 30 minus x will represent the length of the other side. Once again, we use the area formula, length times width, and the information from our picture to come up with a of x is equal to 30x minus x squared. Finding the domain likewise will be similar. Both sides here have to be non-negative. So if I simplify or solve the second inequality, it's a little quicker. I'm going to subtract the 30, again dividing by a negative to get just x, and flip that inequality so it tells me that my x has to be between 0 and 30. Now the maximum, this is also a parabola that opens downward, so the maximum once again is going to be at the vertex. We're going to use the same formula, opposite of b over 2a. So b in this case is 30, A, there's no number there, but I know that means there's a 1, so my A is -1, and when I simplify, I get 15. We'll plug that answer into the 30 minus x expression and get 15, so our answer for this one would be 15 yards by 15 yards.